modern electrical systems have a lot of safeguards in place so people don't electrocute themselves. As you remember, electricity can be very dangerous. It's ubiquitous in our lives unless you live in a society that shuns modern convenience. The electrical safety systems that you typically have in your house or on your device is designed to prevent two different things from happening. It's designed to prevent thermal hazards, which occur when there's electrical overheating. When you have too much current in a wire, the wire heats up and melts the insulation and can create fires. The wire insulation can create fires. There's also shock hazards where current passes through a person, and if current passes through a person, you can burn yourself. You can get to a situation where current passes across your heart, causing your heart to enter an arrhythmia or actually stop beating completely. And of course, these things can lead to death. So we have electricity coming to our houses. Most people like the convenience of electricity, but it's designed to be used in such a way that it's safe. So modern electrical systems use a 3-wire system in the home. There are 3 wires. There's a hot wire, which is usually at the high voltage, 110, 120 volts coming into your house. There's the neutral wire, which should be at 0 volts. And there's the ground wire, which absolutely should be at 0 volts. Now, these modern electrical systems are attached to a box, a breaker box or a fuse box in your house. So each circuit in your house is established to a circuit breaker or fuse, which is designed to prevent thermal hazards. The point of a fuse which were used early on, or if you have a cabin or maybe in a garage that doesn't have an updated electrical system, you might still have fuses. A fuse is simply a conductor that's designed to fail if the current exceeds some value. So for example, if you have a 15 amp fuse, which is a very popular limit for fuses in households, a 15 amp fuse means that once 15 amps or more than 15 amps pass through the circuit, the fuse will melt, breaking the circuit. The idea is that wires in your house should not take more than 15 amps of current, because if they do, they can potentially melt and cause fires. So it's safer to have this little piece of metal in a fuse melt and leave your wires safely protected. Of course, with fuses, you can go down and change an old fuse, put a new fuse in, but if you don't fix what's causing the problem in the circuit, for example, if you have too many appliances plugged in one plug, drawing too much power, drawing too much current, and you just change the fuse will melt again, right? It's designed to prevent overuse of a circuit, too much current flowing through a circuit that's not designed for that. Automobiles, if you have a fuse box in your automobile, and those fuses are, again, designed to fail if a certain amount of current is exceeded, so the electrical system in your car doesn't melt and cause a fire. Additionally, now we have circuit breakers. Most cars still use fuses, even today. New cars will still have fuse boxes in them. Modern houses, though, typically, especially new houses being built and most renovated houses, have what's called a circuit breaker. A circuit breaker is better than a fuse. A circuit breaker is designed the same way. It's designed to trip. It's designed to open the circuit or break the circuit if an amount of current is exceeded. If more than 15 amps goes through a circuit, the circuit breaker will trip, opening the circuit, or 20 amps, or 40 amps, or 50 amps. Whatever limit you need depending on the wiring. Now, we learned earlier on that wiring has different resistive values depending on the diameter of the wiring. In electrical terms, that's called the gauge. Most people in their households have 16 gauge wires, pretty typical. A 16 gauge wire typically, I believe, can hold 15 amps safely. If you need to draw more than 15 amps, let's say you have an air conditioning unit or a furnace or a stove that pulls more than 15 amps of current, then you need to make sure that that stove is connected to the electrical box using a thick enough wire that can, a small enough gauge wire, a thick wire that can handle that extra current load, like a 14 gauge wire or a 12 gauge wire. The lower the gauge, the thicker the wire and the more current it can safely hold. You don't want to overdo it, of course. There's no sense in putting 6-gauge wire throughout your entire house because the vast majority of your house appliances don't use a lot of current. So 14-gauge, 16-gauge wire, these wires are sufficient for most home purposes. But the nice thing about the circuit breaker is it can be easily re-engaged just by flipping the switch. So the circuit breaker is basically a little magnetic spring that when too much current flows through, the spring opens, the magnet releases, the spring opens, and the circuit opens. All you have to do is push the breaker, turn it off, turn it back on, and the circuit is re-engaged. Now, if you didn't fix what was causing the problem in the first place, the breaker should trip again. Always be sure if a breaker trips, look to see what's plugged into those walls. Make sure there's no short circuit. Make sure there's no appliance that's currently on fire or anything like that that might cause issues because you don't want to leave the circuit on in an unsafe state. One of the problems with old fuses is fuses were about the same size as a penny, a copper penny. Well, copper pennies are conductive, so if you push a copper penny in a fuse box where a fuse should be, it acts like the fuse does in that electricity flows through the circuit. But unlike the fuse, it won't break safely if too much current goes through. So what can happen is if you replace a fuse with a penny, that penny will just allow a huge amount of current potentially through the circuit, which can melt the wires in your house and cause a fire. So a fuse box is designed to be a safety feature, but I know for when I was younger, my grandfather would occasionally use pennies if he ran out of fuses as a tide over until he was able to get fuses to replace for them in his fuse box. Is an incredibly dangerous thing to do. And modern circuit breakers are designed so you cannot bypass them like that. Now, more recently, electrical code talks about employing, talks about employing a GFI or a GFCI, as I know them, ground fault circuit interrupter or ground fault interrupter. A ground fault means that when the hot wire supplies current to an appliance, that current should come back through the neutral wire back to your breaker box. If it doesn't, that's a problem because that means the current went somewhere it wasn't supposed to go to. For instance, if you decide to shower while drying your hair, incredibly stupid thing to do, you will die, don't do it. But the electricity coming into your shower, into your hair dryer, should leave through the wire and go back to the circuit breaker. So the amount of current being drawn by the hair dryer is the same as the amount of current that returns. That's how it should work. But in the case of drying your hair in the shower, the electricity can't escape through the water on your body and out through the metal drain in your tub and escape to the earth that way. That's called a short. Well, if that current is going through your tub and through your body, it's not returning along the power line, right? The cord for the appliance. So the current that's being delivered to the device is more than the current that's being returned to the circuit breaker. So what GFI circuits are designed to do is monitor the amount of current leaving and coming in to a circuit. If those two things don't agree, it trips, breaking the circuit, because most likely in that case where it trips, it means that there's a short circuit, electricity is going somewhere it shouldn't. Someone might be being electrocuted, or just electricity might be just going in an inappropriate place, right? The circuit is bad. This is usually installed around places where there's water. So if you have a sink in your kitchen, there are probably a GFCI circuit near there, or a sink in a bathroom. But your bedroom appliance, your bedroom plug probably doesn't have a GFI circuit because you don't play with water in your bedroom typically. Now finally, the ground wire. The ground is an important part of the modern circuit, and the ground wire was added, I don't know, decades ago. But if you own an old house, my house was built in 1924, it has what's called knob and tube wiring. This is not the modern 3-wire system that we have today, but rather just 2 wires, a hot and a neutral. The problem with that is some appliances, if they are electrically charged, if they have a metal case on them, If you short to the metal case, say you're using an old school drill or an old school saw that's a metal case on it, if the interior electronics break down and the hot wire touches the case, you could get electrocuted. So modern three-wire systems have it designed where objects that have metal casings typically will have a ground wire. That way the electricity can safely escape through the ground wire, through your house, and return to the earth rather than going through you. Electricity likes the easiest path to get back to the earth. And if that path is you, it will go through you. But if that path is through a copper ground wire, it will prefer to go through the copper ground wire. So if you have an old house like me that doesn't have a ground circuit, you either have to pay an electrician an exorbitant amount of money to rewire the house. That could be tens of thousands of dollars. You can install GFCI circuits on the circuit breaker to monitor the amount of electricity coming through the hot and the neutral wires. So if there is a short, it cuts the circuit off, and that is allowed by code in some places. Or you can buy those devices where basically you take a 3-prong outlet into a 2-prong outlet, plug it into your 2-prong outlet, and work that way. That's not recommended because objects that have a grounding plug for a reason. You should never, ever, ever cut off a ground plug so it fits in a 2-prong outlet. There are things you can buy very cheaply at Menards, Home Depot, Lowe's, these types of Ace Hardware, these types of stores where it's a 3-prong to 2-prong adapter, but don't cut off the ground prong ever in a circuit. You damage the equipment, you can cause some serious problems for safety if the equipment malfunctions. If the equipment doesn't malfunction, you're safe, but you can't guarantee the equipment's not going to start malfunctioning and could electrocute you. So ground wires, typically, if you go to your circuit breaker down in your basement, you can actually see the ground wire come up, and it's usually attached to the plumbing in your house. Most of us have galvanized pipes or lead, copper pipes, copper or galvanized steel. Those pipes go into the earth, they go into the ground. So the electrical system is attached to the ground, literally to the earth. So excess charge has a way of escaping out, not through a person. So these are modern safety systems and devices. Your book talks about a few others that you should read up on. But modern electrical systems are designed mainly for safety, that hopefully if you use your electricity properly, it won't kill you. But if you're uncomfortable with the circuits in your house, if a circuit is exposed, if you can see wires hanging off, if you have knob and tube wiring that's not behaving properly, definitely call a professional electrician. You need someone with experience and knows what they're doing, and he or she will, bring your house up to code. It can be expensive though.